Good evening and welcome back. In today's session, I would like to discuss how to expand sine A plus B. Let us see the proof. And I initially draw a diagram, it looks complicated, but I would show you how I drew this diagram. Starting with OX, which is the line, and I rotate this straight line with an angle A and name it as OY. Now I would rotate this line OY in the same counterclockwise direction with an angle B and name it as OZ. Right? Now, from OZ, I will draw a perpendicular to OY and I will draw one more perpendicular to OX. So I'm drawing two lines which are perpendicular, one to OY and one to OX, and name it as PR and PQ. Now I consider the line OY. From the line OY, I would draw a line perpendicular to PQ and OX. The line perpendicular to PQ is named as RT and the line perpendicular to OX is named as RS. If you see that I've shaded this angle which is A, and if you see this angle just alternate. So when these two lines are parallel, when two lines are parallel, the alternate angles are equal. I know this is 90-degree here and you see this straight line TR, and its TR is obviously parallel to QS. So therefore the alternate angles are equal. Since this is 90-degree, the small angle here, the small triangle, this one, supposed to be 90 minus A. Since this angle is 90 minus A, the third angle should be A, because all these three forms 180. Angle on a straight line is 180. We have this angle which is 90 degrees and we have one angle which is A, and this is supposed to be 90 minus A. Since this is 90 minus A, the same logic applies here to this with this small triangle PTR, and this angle at P is A, right? Now sine A plus B, I consider this right angle triangle OPQ, and sine A plus B is this angle, which becomes my given angle now. And we know how to define sine of a given angle: opposite over hypotenuse. Opposite here is PQ and the hypotenuse here is OP. So I hope you guys are familiar with defining trigonometric ratios. Now this PQ can be written as PD plus TQ divided by OP. And I split the numerators. I write this as PT over OP plus TQ over OP. If you see, PT is part of the small right angle triangle and OP is part of another bigger right angle triangle. So what I'm trying to do here is I will try to include a line which is common to both, a line which is common to both. And if you see, PR is a line which is common to both the triangle, the smaller triangle and the larger triangle. If you see this PR is part of this right angle triangle PTR, and PR is part of the right angle triangle OPR as well, right? So therefore I would include, because if you just simplify this PR and PR, the same as PT over OP. I hope you understood. So we try to include a new line which is common to both right angle triangles, from which I could define cos A, sin B, etc. Next, TQ. If you see TQ is not even part of any right angle triangle. So I try to replace TQ as RS. So that is how I've written RS over OP instead of TQ over OP. Now the same logic works here. RS and OP. RS is part of this triangle and OP is part of another right angle triangle. So I'm trying to find a line which is common to both right angle triangles, which is obviously OR. So OR is common to ORS and OR is common to OPR. Both right angle triangles has the common side OR. That is the reason why I choose OR. Therefore, RS divided by OR times OR divided by OP. The same thing here, if you just cross them out, you have same as the previous RS over OP. Now, if you see this ratio, PT over PR, PT is here and PR is here. For the given angle A, this is adjacent over hypotenuse. That is the reason why I wrote just cos A. Next ratio, PR over OP. PR over OP. So for the given angle B, PR is opposite and OP is hypotenuse. So therefore it is sine B. Opposite over hypotenuse is sine B. Likewise, RS over OR. RS over OR, which is opposite over hypotenuse for the given angle A. Therefore, I could write this as sine A. OR over OP. OR over OP. For the given angle B, it is adjacent over hypotenuse. Therefore, it is cos B. From which we have the expansion cos A times sine B plus sine A plus cos B, which could also be written as sine A cos B plus cos A sine B. So therefore, sine A plus B has an expansion which is sine A cos B plus cos A sine B. And now something called as the double angle formula, from which we have, which is 2 theta. Sine 2 theta is called as the double angle formula. And sine 2 theta could be written as sine theta plus theta. In place of A and B, now we have theta. A is theta and B is also theta. So sine A cos B plus cos A sine B, just sine theta cos theta plus cos theta sine theta. I just replace A and B to be theta. Therefore, sine 2 theta could also be written, always be written as 2 sine theta cos theta. And this is the proof of double angle formula which follows sine A plus B. So in my next video, I will do the proof of cos A plus B, just the same argument. Likewise, we will prove sine A minus B and cos A minus B. So thank you for watching, and if you have any questions, please do comment and like, share and subscribe, and I will see you all in my next video. Thank you for watching.